Okay, cool. Hi, I'm Drew, and in this video, I'm going to be explaining in very basic terms how a ion thruster works, also called a gridded ion thruster. And so pretty much in order to understand what's going on here, we have to start off with a very basic understanding of the electrostatic force. And the electrostatic force might sound a little bit scary, but I promise you it's really very simple, and you all already know it, I guarantee. You know that like charges repel and opposite charges attract. That is the entirety of the electrostatic force. So essentially, if we have two positively charged ions, then they will be acted on with a force and accelerate away from each other, and this will be the electrostatic force. And if we have two negative ions, the same thing will happen. If we have one positive and one negative ion, they will both be acted upon with the electrostatic force and accelerate towards each other. And so pretty much this theory is applied in a ion thruster. So we have an image of an ion thruster right here, and I'm going to go through each part and explain to you what's going on. So pretty much what we have is at its base just a thruster-shaped body, and we have propellant that is being injected into here, right? And so you have propellant that's being injected in, and then also you have electrons which are being emitted from a hollow cathode. And so pretty much what happens is you have a whole bunch of propellant, which is just these neutrally charged molecules, and then you have the electrons. And when the electrons collide into the neutrally charged atoms, the propellant atoms, with a velocity, they force the propellant atoms, which are neutrally charged at this point, to release electrons. And so pretty much what happens is this starts a chain effect where electrons are then released from each propellant atom, and then more electrons hit each propellant atom, and it compounds and compounds and compounds until there's a ton of electrons and a ton of propellant atoms which have been hit by electrons. And what happens to these propellant atoms which have been hit by electrons is they turn into positively charged ions. Cool. So then pretty much what happens next is you have this soup, right? And what the soup is it's plasma, right? And what plasma is it's just a lot of ions that are positively and negatively charged individually, but as a whole, they're all the soup is neutrally charged, right? And so what happens to the soup? So you have the positively charged ions, right? And they accelerate towards this first field here because they've been hit with a velocity and they're going out away from the thruster, right? Because they've been pumped in that way. And first they pass through a positive um, plate, right? So they pass through a positive field. And then when they pass that, there's a very, very strong negative field, negative grid, right? Which accelerates the positively charged ions with a very, very great velocity out of the ion thruster. And so that's pretty much all you need for an ion drive to actually work. And there's two other components to the ion drive which are also very important, but are not technically necessary. So the first one is the magnetic fields. You can see up here, there are magnetic rings around this image of the ion thruster. And so what the magnetic field does is it makes it so the ionization that occurs is more efficient. So pretty much it makes the electrons move outwards and collide into more neutrally charged propellant atoms to create ionized, positively charged ions, right? Um, and the other thing that's going on that's interesting and not technically necessary, but is very necessary for any real spacecraft applications, is you have this neutralizer. And so what happens is after you have the positively charged ions accelerating out the back of the thruster, electrons are injected into the ion beam, and they are therefore neutralized. The ion beam is neutralized. And so what would happen if it wasn't neutralized is over time, the ion thruster itself would become generally negatively charged. And if it becomes negatively charged, a lot of bad things can happen, because, like we talked about before, opposites attract and like repel, right? So if we have something else that's negatively charged nearby, it might go flying away from the ion thruster, which is something we don't want in space. And along with this, too, that negative charge is going to corrode the efficiency and the thrust that the thruster can generate over time because there's going to be less of those positively charged ions accelerating out of the thruster. Yeah, so that's a basic explanation of the ion drive. I didn't want to go into too much detail here because I wanted to focus more on some other more interesting types of electrical propulsion. And you can find a lot of resources about this online. But let me know in the comments if you have any questions, and thank you so much for watching.